record on this computer, and my wife keeps on texting me. All right, so we have 22 numbers there, agreed? So what I want to do with you is I want to do a frequency distribution with 5 classes. So we're going to call this a group frequency distribution with 5 classes. So the first thing we need to do is we need to find our range. We need to find our range. And our range here is maximum minus the minimum. What's the biggest number there? Now, and what's the smallest number? 5. So 118. Now, usually I had given this to you in the past. Yeah. Don't forget, I was going to repeat what you just said for the video. I don't know. In the past, I've given you these numbers in order. That's what I've done. In out of order, sorry. This case, it's going to be out of order, right? So you need to make sure the numbers are in order. If not, you can't do this. Okay. So now I'm going to ask you to do classes. So the number of classes we want is equal to 5. So how do we do the class width? What do we do to do the class width? It's defined as the range divided by the number of classes, right? So 118 divided by how many classes? 5. She broke her back?
I don't know how I keep questioning it all the time.
Oh my gosh, pobrecita.
I had no idea. I just remember waking up and my mom's like, go back to sleep. Your grandma's in the hospital. I'm like, oh, okay.
Oh. Well, I'm sorry.
Broke a leg or something.
Her back. Wow. So guys, what did we say? What we're supposed to do with this class with? We're gonna always round up. Remember to always round up to the nearest convenient, in this case, integer. Even if we would have gotten 23 exactly, we would go up to 24. That's the agreement we made in this class. Don't forget that. Some of you may have come into the class a little bit late and weren't part of this original lecture. You can go back to those lectures where I'm going over how to do this. Okay. So now we can begin to create our frequency distribution. Our class here, and then we're gonna do our frequency. So what's the smallest number? 5. 5. Okay. And now, how do we add our class width? Downward.
Yeah, downward.
What's 24 plus 5?
29.
What's 29 plus 24? 53. What's 53 plus 24? 77. What's 77 plus 24?
91. Oh, no,
101. So we got our lower class limits there. And now we want to do our upper class limit. Now to get the first upper class limit, we look at this one here. And I ask you, subtract 1. Yes. So it's 28. And then now you might just go 28 plus 24, which is 52. By the way, 52 is 1 less than 53. 52 plus 24 is 76. By the way, 76 is 1 less than 77. 76 plus 24 is 100. By the way, 100 is 1 less than 101. So conceivably, you can just find the first upper class limit. And since the class width was conserved, you can just add the class width over and over. But the last one, you have to surely do 100 plus 24, which is 124. Okay, so now we have our classes and we're going to do our frequency. From the numbers up top, how many numbers are from 5 to 28, 5 and 28 inclusive? 4. 5, 14, 14, 14 meet that criteria. How about from 29 to 52? How many numbers do I have there? 3, agreed. How about 53 to 76? 3. How about 77 to 100? 11, because 100 counts. Does 100 count? How about 101 to 124? Now, if I add up all these numbers, how many numbers should I have? If I add up all these frequencies, I should have 22. Because there's 22 numbers from the beginning, right? 4. If there's 23, then I miscounted. So when 4 plus 3 is 7, 7 plus 3 is 10. 10 plus 11 is 21 plus 2, 23. So that means we miscounted. Let's see where we miscounted. The first class we did fine. Second class, we did fine. Third class. The third class is 2. It's just 48. Sorry. 69, 72, 77 doesn't count. 77 is counted in the other one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we're good. We have exactly 22. Are we done? No. So we're going to go ahead and do right now. I'll just go ahead and get relative frequency over with. Relative frequency. I'll go ahead and write it completely. Relative frequency. So the way we do relative frequency is you write down the decimal 4 divided by 22. Then you do 3 divided by 22. Then 2 divided by 22. 11 divided by 22. 2 divided by 22. I'll go ahead and write the approximations next to it. My calculator is open, so I'll go ahead and try and use it. 4 divided by 22 is 0.18. 3 divided by 22 is 0.14. 2 divided by 22, 0.09. 11 divided by 22, that's 0.5. And 2 divided by 22, that's 0.09. And now I should check that the sum of my frequencies divided by the total, my sum of my relative frequencies should be 1. However, most of the time, when we round the decimals for relative frequency, we don't actually end up with 1. We end up with something less, 0.99, 1.01, 0.999, 1.001, or 1.01, depending how much we rounded. You shouldn't end up with something like 1.2. You shouldn't end up with like 0.97. It should be very close. So if I take 0.18, give me 1 second. If I take 0.18 plus 0.14 plus 0.09 plus 0.5 plus 0.09. In this case, I end up with a really nice number. I end up with 1.0. So I'm good. I know I didn't make a mistake. I could have made a mistake on my classes, but I know I counted everything and I rounded appropriately, hopefully. So now the next thing we have to do is we have to do our class midpoints. Remember when we did this, right? We've done this, right? Yes. All right, so now, how do we do our class midpoints? Very simply, you take 5 plus 28 and you divide that by 2. So 5 plus 28 and divide that by 2. So you get 16.5. Now, you can go ahead and keep on doing this. You can do the next one, 29 plus 52 divided by 2. And 53 plus 76 and divided by 2. And keep on going. Or you just add 24 over and over again. So if I add 24, I will get my next one. Assuming I did this one correctly, the next one should come out to 40.5. And if I add 24 to that, I get 64.5. And if I add 24 to that, I get 88.5. And if I add 24 to that, get some other number, 112.5. I'll grade it in a bit. I'll grade it in a bit. All right, so now we have to do our class boundaries. Well, yeah, let me do cumulative frequency though. Remember cumulative frequency? Remember that? By the time we get to 28, how many numbers will we have counted? 4. But by the time we get to 52, how many numbers we would count it? What's 4 plus 3? By the time we get to 76, what's 4 plus 3 plus 2? By the time we get to 100, what's 4 plus 3 plus 2 plus 11? 20. And what's, by the time we get to 124, what's 4 plus 3 plus 2 plus 11 plus 2? And we should have the same amount of number that we have here total. We should have it there in the last class. Now, any of you who are a little rough on this, you can go back to the other lectures on YouTube. You can look at your notes. And of course, we're not going to test after Thanksgiving. That would be rude. However, after I ask you to review and go over things and answer questions for you on an individual basis, the class after we test, giving you some extra time to prepare. All right, class boundaries. So we're going to have to subtract half and add half because we have a gap between our classes. Remember, the reason we want the class boundaries is because we want to have an x-axis that we can use to graph a histogram. That's what we want to do. So in order to eliminate the gap of 1 between 28 and 29, we're going to go add half and subtract half. This is not always, but most of the time this is the case. So we subtract half to 5, we get to 4.5. We add half to 28, 28.5. And we repeat this in the bottom one, we end up with subtract half, add half. Subtract half, add half. Subtract half, add half. Subtract half, add half. And now we create our class boundaries. So this is like an important section of this test. What time does this class end now?
I think it's like, it's not 10.
Let me tell you right now. Remember, guys, why am I making sure that today, even though it's like kind of like a day that people should chill, maybe want to chill, why am I going through trouble in teaching you? Oh, no. Didn't you hear my conversation at the beginning of class? Okay. Yeah, we end at 9:43. A bit open. Okay. So the reason is because the only reason I wouldn't teach you today is because I could be lazy. Now, right now I'm looking out on the class. I see many of you are being lazy. In fact, some of you have been so much corrupted by your little phones, your little electronic devices that you don't even fully understand. That you can't realize right now that what I'm trying to impart on you is your ability to reason and use your mind. And that's the only reason you're in school, because you're not going to use any of this in life, right? The only thing that is important about you is your reasoning, your ability to think. That's the only thing that makes you different from a pig or a cow. There might be cynical people out there that think that's not true, but let's ignore that. The only thing that you can do better than they can in every single way is to reason, to think. And that's what you're doing in school, hopefully. You're preparing yourself to have the highest reasoning you can. All right? That's the only reason you have been here. Because you can tell what's the purpose of a lion. It's not to reason. But the purpose of the human, that's pretty much what you can narrow it down to. So it stands to reason that if you're using your reasoning, you would realize that your laziness is a thought process you have that you need to be able to circumvent or to dominate. Think about that for a second. So anyways, let's continue. All right. So now what if I ask you to do some graphs here? Can I ask you to do a histogram? Yes. Well, I'm going to ask you a histogram and you're going to ask me, well, what do I use? Do I use a class midpoint or do I use a class boundaries? What if I ask you to do a frequency histogram and I want you to use midpoints? Could you do it? All right, so the frequencies go up to 11, right? So I'm gonna pick my scale. I'm gonna go by ones. I think it's one's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I'm gonna go ahead and use my midpoints. My midpoints are 16.5, 40.5, 64.5, 88.5. You hear the bird? Does the bird reason? You heard him, right? Does the bird care about all the problems that are happening in the world, or it doesn't even know that there are problems? It doesn't know. It doesn't even care. It just does what it does. It lives and dies. It happens. How long do birds live on average? Do you guys know that?
It's like about 4 to 5 years.
4 to 5. That's pretty good, though. I think that's a pretty good life. All right. So for 16.5, how far high does it go?
It goes up to 4.
Can you imagine the bird coming in here and like starting to sing on my shoulder? Wouldn't that be cool?
Very low times.
You see what I'm doing there? Oh, this is bad. Look, I gotta make sure for the midpoint. What should I be making sure that the midpoint is in the middle of the bar? Not the best, but whatever. Look, I'm spinning, and it can be seen in the camera up here. And I'm spinning, spinning, spinning. All right, any questions or concerns? You guys remember that? Sort of, kind of, maybe. All right. How about if I ask you to do a cumulative frequency graph, or sometimes this is referred to as, what's the other name we use for it? It starts with an O.
Oh,
O guide.
oh, guys.
Yes, O guide. So now let's go ahead and do that. Emotions. And we have to use here. See, in the previous one, in the frequency histogram, we could have used class boundaries. In other words, we could have done that one, and I'll go ahead and kind of like, we could have instead have used right here. We could have put that on this tip here. I guess I'll do this with blue. We could have used 4.5 if we wanted to. And so let me go ahead and just go back on that for a second. Right here, we could have used a 4.5, and then this guy here would have been 28.5. And we, and right here, this one would have been 76.5. No, 52.5, sorry. 52.5. And this one here would have been 76.5. And then this one here would have been 100.5. And then this other one here would have been 124.5. We could have done that. I could have asked you to do it that way. That's why in the test, I'll tell you what I want you to use with histograms. And let me erase that because when I export that to the notes, it doesn't look very pretty. But now for the cumulative frequency graph, you have to use class boundaries. You have to use class boundaries. So this is going to be 4.5. This is going to be 28.5. This is going to be 52.5. Sorry, 52.5. 76.5. Today I'm going to push a 28-hour fast, man. 28 hours. I may even push it a little bit further, but I think 28 hours is good. If I manage a 28-hour, I think it's good. So again, I should have made sure those were the same distance, but this is a sketch. How far up does my cumulative frequency go? I'm gonna go by 5s, just because I don't want to say lazy, but just for convenience. So what's at 4.5? How many numbers would I have counted at our 4.5? Nothing. But by the time I got to 28.5, how many numbers would I have counted? 4. By 52.5, how much?
3, 7,
7. 76.5.
9,
100.5
20,
jumps right up to 20. And for 124.5?
22.
And now we connect the dots. And you're done?
Yes, sir, I have a question.
Yes.
Will there ever be a point where the first class, like the first set of the class boundary will have like at least one number?
No. The reason is because we purposely, when we started here with the smallest number, 5. We'll go to 4.5. How many numbers were 4.5 in there were none. So it's impossible. So but we made it that way. All right. Now, here's the great thing. What if I asked you to do a frequency polygon? It is a closed shape. So now I want to go ahead and do it here. A frequency polygon has to use midpoints. So what's convenient is right now here, I have midpoints there. So for 16.5, it was 4. So I put a dot there. For 40.5, it was 3. For 64.5, it was 2. For 88.5, it was 11. And for 112.5, it's 2. And so I connect these dots like so. In fact, before I connect it, let me go ahead and erase the bars because the bars should go. And as you can see, this wonderful piece of technology allows me to do this while it also is seen on the board. Don't you think that's pretty cool, guys? The amount of infrastructure you need to do this is immense. We take that for granted. Think about it, the amount of infrastructure that needs to be in place for this to happen right now that I'm doing is immense. Because this is not even local. This is being sent to the internet and this goes to a server, I'm assuming from Microsoft. And then, so I'm doing it here, it goes to Microsoft for some server, then it comes back here and reflects in here through the internet. Isn't it that incredible? And for all purposes, it's instantaneous. You're saying, oh, delayed. Yeah, sometimes it delays, but you know, most of the time I'm doing this and I look, I connected. Bro, you saw that? Look. Boom. Isn't that like magic? Woo. Practically instantaneous. Look at that. But am I done there?
No.
I have to create 2 additional midpoints. Why? Because we have to close the figure. Our class width here was what? 24. So now I gotta take 16.4 and subtract 24. So this here, which you can't see, but I'm gonna go ahead and write in color. This here should be negative 7.6. I'm gonna choose it right here. So this closes down here. Boom, negative 7.6. And then for 112.4, 112.5, sorry, I have to add 24 to that. I got 136.5. And now I've closed my shape. And that is a frequency polygon. So you're going to be expected to know this and something I'll review with you next class, which will be after Thanksgiving. The stuff that we've done recently in terms of the box plots and the empirical rule. And then you'll be ready for your test, which you'll take, and it'll be worth a substantial amount of grades. It will balance out those 5 other grades. And then we'll go into chapter 3, and we'll do chapter 3 and chapter 4 in December, part of January, so that when we start the next 9 weeks, we'll do chapter 5 and chapter 6. And the 4th 9 weeks, chapter 7. And maybe I'll skip 8 and go to 9, or maybe I'll do a short version of 8 and 9, and we're done for the year.
Just a question.
Yes.
To get the first and the last midpoint, you had to add and subtract
The class width.
right?
Yes, add and subtract the class width to get those additional midpoints.
So the first one, the